Hello everyone, I am Sheikh Sady. I am from Comilla University studying at Department of CSE, and today I'm going to talk about KNN Classifier in machine learning. And so if you're not new in machine learning, so you may have come across to KNN Classifier a lot of times. But if you are someone new in machine learning, this presentation is going to help you understand what actually KNN is and how does it work. So without further ado, let's get into it. So basically, KNN is a machine learning algorithm um, that is used to identify unknown data points based on their similarities with other data points. So it's a supervised learning algorithm that works with labeled data. And so what actually KNN does is it looks for similarities among its neighbors, and it outputs that class which it is most similar to, and it does that. It does this by getting votes from its neighbors. So yeah, we're gonna look into this, the voting system. We're gonna look into this, but yeah, let's just move on. So KNN is basically used in classification tasks like pattern recognition system, or any binary classification or multi-class classification. But it can also be used in regression as well. So for regression, what it does is it predicts a value by calculating the average of its k nearest neighbors, and like this it calculates the regression values and does its appropriate jobs. And so we are talking about k nearest neighbors. So how do we actually calculate the nearest neighbor? So for that we have some distance metrics like Euclidean distance, Manhattan distance, or Minkowski distance. And if we carefully observe the formula for Minkowski distance, we can see that this is actually the Euclidean distance is actually a specific version of the Minkowski distance for k equal to 2, for q equal to 2 actually. So, and the Manhattan distance is actually very basic one. What we do here is we simply take the absolute value of the coordinates and add them up for getting the Manhattan distance. And here's a catch in the distance calculation. So it may happen that sometimes it may happen that the data we are working with is not numeric in nature. So then how we are going to calculate the distance? For that we have some techniques in machine learning, but this is not something we're going to discuss in this presentation. But surely there are some techniques for doing that. And now comes the most important part, the voting part, and it's called the concept of majority label or majority voting. So as we have said earlier, that KNN takes votes from its neighbors and decides which class is going to be the output class. So let's just look into the image in the slide for better understanding. So here k is equal to 5. That means we're going to look into its 5 closest neighbors. So for the unknown data point, yeah, 5 of its neighbor out of five of its neighbors, 3 of its neighbor is referring to the green class, 2 of its neighbors are referring to the red class, and only 1 is referring to the blue class. So according to majority voting, we're going to go with the green class because it is having the most vote. So yeah, this is how the concept of majority voting works, and this is probably the most important part in KNN classification. And after that, one more important thing is how do we select the number k? So honestly speaking, there is no predefined rules for selecting the optimal k. So what we can do for this is iterate over some values of k and finding out which k gives the best results. But to start with, we can take k equal to a square root of n, where n is the total number of data sets, total number of data points available in our data set. So yeah, this is what we can do, and let's just look into the image for seeing that how changing the value of k changes the results. So firstly, the value of k was 3, so we're gonna look into three of the closest neighbors. So out of the 3 of the closest neighbors, 2 is referring to the red class and only 1 is referring to the green class. So according to majority voting, we are definitely going with the red class. But this scenario completely changes when we change the value of k from 3 to 7. Now out of the 7 closest neighbors, 5 of them is referring to the green class, which was not the same for k equal to 3. So now according to majority voting, we're going to go with the green class. So this is how changing the value of k actually changes the results. So selecting the optimal k is also very important, and it is always recommended that we take an odd number as k, because sometimes it may happen that uh, two or more uh, uh, two or more classes are having ties as the majority votes. So if we take an odd number as k, then this issue will be solved. And after that, class level assignment, once the k nearest neighbors are identified, the KNN algorithm assigns a class level to the new data points based on the most common level among those neighbors. And it's simply saying that after we are done with finding out the appropriate class of an unknown data point, then we are going to level that data point to some particular class, because it is going to help us identifying more unknown data points in future. So this is what the class level assignment is actually saying. And so yeah, this is all from me, and thank you everyone.